factor. That wouldn't be impossible, but it's not that great. Factor the numerator. So what does this D stand for right here? Domain. So x can't be -6 or 1. So that's after canceling, which there is nothing to cancel, so the vertical asymptotes are -6 and 1. So what could you immediately draw in right there? After you know what the vertical asymptote's in, what could you draw immediately? Yeah, x equals -6 and x is equal to 1. Exactly, right. So then you found it finds the intercepts, 0, 0, and 3, 0 for the x-intercepts. So those intercepts are right there and right there. So if you have the two intercepts, then you could find the, you already found the y-intercept because 0, 0 is both an x-intercept and a y-intercept. Exactly, very nice. Nice, and then the end behavior tells us what the horizontal asymptote is going to be. What's the degree of the top? 3. What's the degree of the bottom? So the only thing that's going to matter are the leading coefficients. And what's the leading coefficient up here? And what's it on the bottom? So therefore the leading coefficients are going to be the horizontal asymptote is going to be y equals 5. Sorry, yes, exactly. So because of the intercepts, for example, you know that this thing hits right here at 0, 0. So you know it's going to have to go, well, actually, that's a good question. How do you know if it goes up or down?
Because you can't go up.
Well, that's the thing. One thing we haven't checked on this is can it cross the line y equals 5? Remember how we've checked that sometimes, right? Is it possible to cross horizontal asymptotes sometimes? It is possible. Sometimes it's really hard to find, though, is the problem. We can try it, though. Let's try it and see what happens, okay? If we want to cross a horizontal asymptote, that's a y value. So it's going to be, what's the original equation here? So what does that original equation have to be equal to if we were going to have it cross the horizontal asymptote? What was that going to be equal to? Well, what's the horizontal asymptote, kids? 5. So what does it have to equal if it's going to cross? It has to equal 5, right? So what's the original equation? It's 15x cubed, right?
5x cubed.
No, what's the unfactored one? Oh, it is 5x cubed. I'm sorry. Sorry, excuse me. 5x cubed, yep.
Minus 15x squared.
Minus 15x squared. And then what's the factor form on the bottom?
X plus 6, x minus 1,
X minus 1. Like this?
Yes.
You set it equal to 5, right? That's what you theoretically want to solve that. This is a little bit of work, but it isn't impossible for you to do. Something very nice happens halfway through. What do you think you have to do first on this if we want to solve this? What do you have to do first? I'll give you a hint. Not factor.
Do you have to put it back together at the bottom?
Yeah, you have to multiply it out, right? So let's multiply it out and see what happens here. You multiply this and you end up with x squared minus x plus what? 6x minus 6. And this all gets multiplied by what? Before I multiply again, what should I do to the big thing on the left? Combine like terms, and what do you end up with? X squared plus 5x minus 6 equal times x minus 1. Now what do I need to do? Multiply it again. So we multiply this through, we end up with x cubed minus x squared plus 5x squared, right? Minus 5x minus 6x plus what? Plus 6, right? So that's the denominator. So if this is the new denominator right here, this is the new denominator. So that that's the thing on the bottom. What do you do when you have a fraction equaling a number? What can you do to solve that? Multiply by the yeah, so cross multiply. It's effectively the same thing. So what do we now have? We have 5x cubed minus 15x squared is equal to 5 times this thing, right? Correct?
Yeah.
So if we do that out, what do you end up with? 5x cubed minus 15x squared is equal to, we multiply by 5. So what is it? 5. Oh, do we have some like terms we can combine here?
Yeah.
So if let's simplify it. 5 times, what are the like terms here? We have x cubed, right? How many x squareds do we have? 4 of them, I think?
Yeah.
4x squared minus 11x plus 6, right? So we have 5x cubed minus 15x squared equals 5x squared cubed, thank you. 20x squared. 55, thank you. I can't, thank you. Plus what? Does something cancel on both sides? What's the first thing that cancels? Is that really nice that it cancels? Yeah, we don't like dealing with the cubes, right? And then if we want to solve a quadratic, we want to make it equal 0. So let's add 15x squared to both sides, like this. Oh, that actually goes right there. So what do you have? 0 is equal to what? X squared minus what? 55x plus what? What can now it's equaling 0, which is what we wanted, right? So what can we factor out first on this? A 5. 0 is equal to 5 times 7x squared minus what? Plus what? Plus 6. And now, I know, we look at that and we're like, I don't want to deal with that. There's one nice thing. Okay, the leading coefficient of 7 isn't 1. We like 1, right? But at least 7 is what? Prime, right? There's only a limited number of ways to break it up. So if we want to factor this, we end up with 0 is equal to 5 times, we know it's going to be 7x and x, right?
Yeah.
But now we have to be really careful, right?
Isn't it 7 minus?
Wait, what? Minus what? Minus
Minus 2.
2 and maybe minus.
3.
It's got to be minus. It's got to be both negative, right?
Yeah.
So what would that be? It'd be minus 14. That's minus 17, right? That's too big, right?
Yeah, if there was a plus.
You see what I mean? So what do we do now? Minus 6. And if that's minus 6, the other one has to be what? Minus 1. Is that closer? But does that work? Does that work? So if you get an inkling that it's not nicely factorable, if you get an inkling that this right here is not nicely factorable, right here, if you get an inkling that's not, what do you have to use? Quadratic formula. And what's the discriminant? Can someone remember what well, first of all, let's just write out the quadratic. X is equal to what? Negative b
Plus or minus the square
root of.
b squared minus 4ac over 2a.
Where's the discriminant?
B is squared minus 4.
Yeah, this, not the root, but the thing underneath. So that's what you find first. Do that first. So in this case, what's a equal in this case? 7. What does b equal?
11.
C equals. So b squared minus 4ac is going to be negative 11 squared minus 4 times 7 times what? 6. What's 11 times 11?
121.
That's going to be minus 28 times what? 6. So it's going to be, so that's going to be 121 minus what? 168. What does that equal? What does that equal?
Negative something.
Oh, come on. Negative 47. If the discriminant is negative, what does that tell you?
It's not possible.
Well, it is possible, but with imaginary numbers, right? This means that the answer to this is going to be negative 11 plus or minus the square root of negative 47 all over 14, right? This number is what? 11 plus or minus I root 47 all over what? 47. What kind of number is this? This is two numbers. What is this? It's complex, but this is more importantly, it's imaginary. So we just asked the question, where does this cross?
Why is it over 47?
14th, sorry. I just really like the number 47. It's over 14. So here's the thing. We just asked the question, where does this cross the horizontal line y equals 5? And it gave us an imaginary answer. So what does that tell us? It doesn't cross a real line. That's a lot of work to do that. So generally speaking, I'm not going to ask you to do it unless it's super straightforward. But that's important to know, right? We know it doesn't cross. So here's the thing. If it doesn't cross, can it start here and go up?
No.
Why not? Because then it would cross, right? So it has to go down. And we know it crosses there, correct? And it gets infinitely close. So what does this have to do? It has to go like that, correct? Because it can't go up from here. Why can't it go up from here? Because it would cross the horizontal asymptote, which we know it can't do. So it has to go down. Remember what I said about the powers of the denominators? What do you see twice right here? What do you see twice? X minus 1 and x minus 1. So what's the power of x minus 1? 2, which is what type of number? 2 is an even number. I know, it wasn't very specific. You're like, 2 is a nice, I like the number 2. Need more, Mr. Seaman, need more. Okay, look, the power of x minus 1 is even, right?
Yeah.
What does that tell you about the behavior on the asymptote? Odd means they go in different directions. Even means they go in the... So we knew this one went down, so this one has to go down as well. If it's odd, they go in opposite direction. If the power is even, they go in the same direction. Because x minus 1 is there twice, x equals 1 is the horizontal asymptote induced by it, so they both have to go down. That's another reason. But then look at the other one, x plus 6. What's the power of x plus 6 right there? 1. So they have to go in opposite directions. This one goes down, so the other one has to go up. The other one has to go up.
You didn't say like